This video is for Stat 110 Module 1 Part 4 and is going to include a discussion of a discrimination case. Okay, let's go ahead and get started then. So Module 1 Part 4 is, as I said, about a discrimination case, and it is a case that went before the United States Supreme Court. The name of this case is Greenholz versus Nebraska Penal and Correctional Complex. And the reason that I'm using this case is because in the article provided here, they actually include the data that was from that investigation, which will be nice. We can use that in our investigation then. So these authors here presented a case, again, Greenholz versus Nebraska Penal and Correctional Complex, and they focused on discrimination of Native Americans and also Mexican Americans. In this particular handout, we're going to look at just the possible discrimination against Native Americans. So let's talk a little bit about what the court ruling was in this case. And this is an excerpt directly from the article provided up above. So what they did is they looked at the proportion of individuals that were of a particular race or ethnicity. So what they did is they looked at the number of people that were eligible for parole. So here we can see there is 590 whites, 235 African Americans, 59 and 18. There were a total of 902 people that were eligible for parole. So the first thing that the court looked at was just 590 divided by 902, and that's about 65%. So 65% of the people that were eligible for parole were white. Then what they did is they looked at the number of people that were actually paroled. Okay, so they added up all these values here and took 358 divided by that total, and they ended up with 66.9%. So there were 535 that actually got parole, and 358 of them were white. So if we compare those two percentages, 65.4% of the people whites were eligible for parole, but 66.9% actually received parole. And that's a difference of 1.5%. Now, what they did is they also looked at that for the Native Americans and the Mexican Americans. So if we took the 59, because there was 59 Native Americans, and divided by the 902, you would have 6.5%. And then they took the 24 and divided by the 535 that were available for parole, and you would get 4.5%. And they argued that that difference, which is 2%, was an insignificant difference. So being 2% off was not that much. Now, when we're looking at this, the Native Americans were 2% below what they should have been. Okay? So there were a total of 6.5% that were eligible for parole, but only 4.5% got parole. So we're 2% below what it should have been. Whereas whites were 1.5% above what they should have been. So there is actually more than a 2% difference between, when we go to start comparing across ethnicities, there's a pretty substantial difference there between whites and, say, Native Americans. And a similar thing was done with Mexican Americans. Now, the approach that we're going to take here, so let's look at this table a little bit more closely here. The approach that we're going to take here is we are going to consider those that were eligible for parole and those that received parole, but we're going to do that not considering the ethnicity or not considering the race. So there were, again, 902 people eligible for parole, and 585 of them, or 535 of them, received parole. So I can look at that ratio. So let's do that. We'll do that down below. So we had, again, 902 people were eligible for parole, and of these 902, 535 received parole. So that is about 60% of the individuals received parole. Certainly more were paroled than not. So the proportion of inmates that received parole was 59.3%. Now, this number right here is irregardless of race. That is ignoring race. So if there is no impact to race, I should expect about 60% to receive parole. All right, so a statistician is going to look at those totals, but we're going to do that under the assumption of no discrimination. Or equivalently, if I ignore what race they were, what would the parole rate be? And that was that 60% here. Okay, so now I can build a simulation model under a no discrimination situation. And again, I'm going to do this for the number of I'm going to investigate the Native Americans. So do I have evidence of discrimination against Native Americans? There were a total of 59 Native Americans that were eligible for parole. So my number of trials here, or my sample size, my N value here is going to be 59. And the likelihood or chance of parole, again, we're going to build that under a fair situation, is going to be that 59.3%. So what would be the expected value? Well, the expected value is just simply going to be that 59, because that's how many were eligible. And under a situation of no discrimination across races, I'm going to need to multiply that by that 59.3%. And I see that I should have about 35 Native Americans that got paroled. How many actually got paroled? That number was only 24. So doing this analysis under a situation of no discrimination, we can see that the number that were actually paroled is actually somewhat reduced from the number that should have been paroled. There's a difference of 11 here. 35 from 24. And a difference of 11 is actually quite a bit when you're talking about numbers in the 20s and 30s. So here's what our simulation model would look like here. The label on the y-axis or x-axis is just going to be the number of Native Americans paroled. That can range from 0 all the way up to 59 here. My no discrimination situation is going to be at 59.3%. So again, the middle of that, or the expected value, should be right around 35. Now certainly if they would have paroled 34, that is within the realm of no discrimination. Or if they would have paroled 37, that would have been within the realm of no discrimination. If they're discriminating against the Native Americans, then I'm going to expect that they would have too few people being paroled. So the staring example, I cared about what was going on the right-hand side of the distribution. In this example, I'm going to care about what's going on the left-hand side of that distribution. Because, again, having too few Native Americans paroled is going to indicate possible discrimination. Now, again, the main purpose of a simulation distribution is to identify what are likely and unlikely outcomes. So here it looks like that distribution or that pyramid settles down around 26 or 27, or does the distribution settle down around 18, 19, 20? I don't know where that edge of that distribution is without simulating that data or running that simulation model. Okay, let's look at this table here. That just kind of identifies a whole bunch of different values here. So the lowest possible value that I could have gotten would be 0. There could have been 0 Native Americans paroled. The largest possible value here is 59. There could have been 59 Native Americans paroled. The label, I might ask you on a homework, what would be the appropriate label? And that is just going to be the number of Native Americans paroled there. Expected value is just computed from that simple equation up above there. The number of trials multiplied by that percentage that we're using under our simulation model, and that's about 35. Again, I would expect there to be about 35 Native Americans paroled under a situation of no discrimination. Okay, the side that I care about here is going to be the left side of the distribution, again, because the left side would indicate discrimination. And that's what I'm interested in trying to determine. The study outcome is just going to be 24 here. So the question that a statistician has to identify or answer is, does 24 Native Americans paroled out of the 59 provide enough statistical evidence to suggest discrimination was taking place against Native Americans? And this would be in the state of Nebraska and during this time of the study. So data here was gathered just from the Nebraska Penal and Correctional Facility, so I can only make decisions about what's happening in the state of Nebraska during the time of that study. So how we answer that question is simply to determine whether or not 24 is an outlier against a no discrimination situation. Again, I can fairly build the reference distribution for a no discrimination situation. So how do I obtain outcomes from my simulation app? So let's go ahead and go set that up, and then we'll come back here and talk about what those outcomes imply. So the simulation app, the link for that is provided on our course website under section 1.4. My two outcomes are going to be either that a Native American was paroled yes, or they were not paroled. So my two outcomes are yes or no. They either received parole or did not. What I'm going to use for my P here, or the probability value, again, that quantity is for the success. And that quantity here is 0.593. What this represents is the likelihood of receiving parole under a no discrimination situation. And then my sample size here is going to be 59. Again, my analysis is for the Native Americans, so I'm just going to use the total for the Native Americans. This N value right here actually is always the maximum value on our number line. So the largest possible value here on our number line is 59, and that is the value that we put here in for our sample size or our number of trials. And then we are going to use a count. Again, I am keeping track of the number of Native Americans that were paroled. Later, we're going to start looking at proportions, but for this Module 1, we're looking at counts. Okay, and then we can just click the spin button, and that will automatically So what the app is actually doing is pretending to be paroling individuals, Native Americans, I guess here, at this rate. And I can see that I got 35 that received parole. That column there. You can turn the animation off to go a little bit quicker. There's a 34. 33, 32, 28, 37, etc. So I can just get repeated outcomes here. Okay, let's go back to the notes then. So here's a set of repeated outcomes that I obtained, 38, 33, 27, 35, and I could just keep doing that as many times as I wanted. Now, definition here A statistic is just some sort of summary measurement that we computed from our data. So this value right here would be called a statistic. The 38, the 33, the 27, the 35. These are values or outcomes from my simulation model. And for that matter, the 24 that we obtained from our data is also a statistic. That came from my data that we actually had in the study. Not from a simulation model, but the data that we actually had in our study. And again, what we're going to want to do is compare this statistic to these repeated outcomes from the simulation model. We're going to try to see whether or not this 24 is kind of within the realm of the values from the simulation model or not. Because if it's within the realm of the values from the simulation model, and we know that the simulation model was built under no discrimination, then that's going to indicate that this value is likely indicates no discrimination. However, if 24 is an unusual value against the values from a simulation model, then it might indicate that discrimination was taking place. Okay, so here are 3 plots, and these were each obtained when using 10 repeated outcomes of the simulation. So we can see that for most of these graphs, we tend to be right around the value of 35, which should be the expected value here. But there are some differences. So I'll go ahead and hit pause here and answer these first 3 questions. Okay, so we do have some similarities. We can see that they all tend to be centered right around 35 here. Some of the differences that exist is that this first graph, graph A, looks like we got a value of 27 here, whereas the other 2 were kind of on the edge of 30 and 31. On the upper end, it looks like they're right around 40, 41, 42. When we only use 10 repeated outcomes, it's going to be difficult to separate the likely from unlikely values. And in fact, what one person defines to be likely or unlikely might be different when you don't have very many repeated outcomes. So person A here, or person using graph A, might think that, well, values like 25 and below might be unlikely. Whereas person B might indicate that 30 and below is going to be unlikely. Person C is going to be 29 and below might indicate unlikely. So again, we're very interested in the edge of this reference distribution. And if I don't use a lot of repeated simulations, it's going to be hard for me to define where that edge is at. So the moral of the story here regarding question 3 is that you're going to want to use more than 10 repeated outcomes when trying to determine what an unlikely value is. So here I have 100 simulated outcomes. And we can tell that it would not be a good idea to use values 30 and below as unlikely, or for that matter, 29 and below as unlikely. Because when I got many, many repeated simulations, you can see that quite often I got values up here in this 26, 27, 28, 29, 30. Those were quite likely to happen. Not as likely as 35, 36, 34, but still they happen somewhat often. Here it looks like I added another 100 repeated outcomes. So this picture, I believe, has 200 dots on it. And again, it looks like maybe 24, 25 is kind of where that edge is at. Here I'm up to 350 outcomes. Again, right around 24, 25, maybe 26 is unlikely there. I only got 26 3 times here. So as I allow the simulation app to get me more and more and more dots or repeated outcomes, I am going to become more and more confident on where the edge of this distribution is at. Okay, so let's consider the set of graphs here down below where I got graph A based on only 10 outcomes. I got graph B based on 100 outcomes, I guess. Graph C is actually based on 1,000 outcomes. And then graph D is actually 10,000 outcomes. Now our simulation app will allow us to do this. So if I zoom out a little bit, I haven't talked about the right-hand side of this simulation app yet. You can see as I hit spin here, down along the bottom here, you can see that I'm starting to get a few dots. And every time that I hit spin here, I'm going to be adding more and more dots. So if I keep hitting spin a bunch here, you can see that I'm getting a bunch of dots built up here on this reference distribution. Up here near the top, it says that I have a total of 50 statistics that have been collected. Again, the term statistic is just this count right here. A statistic is a summary measurement that I get from a set of data. So now I have 50 dots here. If I wanted to get up to 100, I could just go ahead and click the 10 button, and now I have 100 values collected here. So this pyramid right here, or this reference distribution that I'm getting from the simulation app, now has 100 dots on it. I can use the 1,000 button here and I can start to get a bunch of them. Or I can use the 10,000 button if I wanted. So here now I've collected, I guess, 59,000 statistics. And what this represents, again, every single statistic on this graph represents what would a selection look like under a fair situation. So if I were to let the computer, let's say, or the simulation app do the paroling under a fair situation, how many would get paroled? The expected count here is 35, and of course that's the one that's going to have the highest bar. Out of the 59,000 statistics, it looks like that about 6,000 of them are at 35. So what we mean by the expected outcome is the outcome that's going to occur most often if you allow this to run in the long term. So over many, 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 many repeated trials. So we can start using the right side of this distribution, we can start using the right side of this simulation app to collect many, many, many statistics. Okay, I will let you go ahead and answer questions 4 through 7. After you submit your solutions or your answers, solutions for these will pop up. So I will let you just go back and check your answers. Let's go to the evaluating evidence stage. So here I'm going to use graph C that had 1,000 outcomes on it. And the number of dots here at 22 was 1. It's kind of hard to see that. But the number of dots here at 22 was 1. The number of dots at 23 was 1. The number of dots at 24 was 2. And then it looks like I had 3 here at 25. And this is out of 1,000 outcomes. So getting a 25 is not going to occur very often. Only 3 times out of 1,000 am I going to get a value of 25. Only twice out of 1,000 am I going to get a value of 24. Likewise, only 1 time out of 1,000 am I getting a value of 22 or 23. So 24 here is sitting certainly on the edge of this distribution. Okay, I'm going to argue that 2 out of 1,000 is unlikely to occur, and certainly 1 out of 1,000 is also unlikely to occur. So to me, from a statistician's perspective anyway, 24 is a somewhat unlikely value. So that's what question 8 is about here. Would you consider 24 to be unusual? And as a statistician, I'm going to argue that it is. Now, our goal with these reference distributions, again, is to determine what values are likely from what values are unlikely. We do not concern ourselves with what is possible. In fact, anything on this reference distribution is possible. It is possible that I would not see any Native Americans being paroled, even under a fair situation. I mean, that's a possible outcome. I could get a value down here at 0. Now, it's not very likely at all. So when we make our decisions from a statistical perspective or through a reference distribution like this, we don't worry about what is possible or not possible. We worry about what is likely versus unlikely. So that's a key distinction when making a statistical decision. So I will let you answer questions 8, 9, and 10 here. Again, after you submit your answers, you can go back and click on your notes to see the solutions that I have provided. Okay, that does it then for Module 1, Part 4, the discrimination case. Thank you much.